We present a brief overview of the team UW Madison's participation in the DiSCo challenge. We performed standard signal corrections by reducing noise, Gibbs ringing, Ricin bias using the tools implemented in MRTrix. We skipped the eddy correction step, assuming numerical simulations would not introduce such effects. We attempted to skip the ringing correction step, assuming similarly, but the scores were slightly lower without the step. For signal modeling, we used fiber orientation distributions from MRTrix with multi-shell, multi-tissue response function with Dolander algorithm with different combinations of white matter, gray matter, and CSF percentages. We also explored some single-shell response function algorithms. We attempted to use generalized Q sampling imaging from DSI Studio. All of these combinations actually provided similar scores with small variations in the third decimal place. We tried to use diffusion models that consider multiple diffusion times, but could not complete those experiments due to various constraints. For tractography, we used IF42 algorithm in TechGen tool from MRTrix and separately Tracker. Tracker gave slightly higher scores. Seed masking did make a difference. We defined seed masking as DC term of the FOD is bigger than 0.02 without the node regions. We explored different combinations of the TACSIF2 and TAC2connectome commands. These were the parameters that were varied for TACSIF2, and we varied different assignment options for the TAC2connectome. These are the top 10 scores on the training and validation sets. Note that the scores on the validation set were uniformly better in the third decimal place, and the majority of the parameters combinations were default. These are the details of the top scoring combination on the test set. Dolander algorithm was used with these percentages. Tracker was used to generate 10 million tracks with node regions for both pathway A and pathway B constraints. These were the parameter combinations for TACSIF2 and TAC2connectome. In conclusion, overall, using the above presented tools pretty much in an off-the-shelf manner resulted in scores on the order of 0.97. The different combinations explored provided improvements in the third decimal place. Seed masking did have a significant influence on the scores. We would be interested in exploring models that consider multiple diffusion times in the future. We would like to thank the organizers for this interesting challenge and funding and support that enabled our participation in it. Thank you.